All right. Happy Monday, y'all. The end of July. Yeah, here comes. Yep, here comes Albrecht Corporate. Joanne Marie and Jay Maz. I gotta tell them you got that they're usually first. They're late. Joanne Marie and John are late.
I'm not late. I'm on time.
That's right. Well, you guys are always waiting, like 10 of.
What do you want from me?
That's some way to say hello, right, Joanne? You're late. Um, I'm kind of excited for you guys now because we're out of that horrible phase that we're in with all the hypothesis tests, and I think it gets a lot more fun, and I'm kind of excited about it. We have 2 weeks left of actually, let me pull up the math practice. Ba-ba-da-da. All right, here's the math practice. Just a quick overview how everybody's doing. So you can see here, not too bad. It's been usually I get a whole bunch of reds here, so this class is doing better than most. Just try to get everybody caught up over the next week or so. I know the homeworks are coming in. It's basically for your benefit, just try to practice some of the things we go through. Um, this week we're going to do correlation. There'll be a little bit of homework, kind of fun though. I find it fun. Then we'll do regression analysis next week, and then we're into the control phase. And the way I do it is, out of 9 homeworks or 10 homeworks, how many did you hit? And then the exam is it's on class marker. You have like we work together on it if you'd like. I email it to you, a link to it. No one's ever failed. And then we do a project where I'm going to break everybody into teams. Teams will probably be like 4 or 5 people each, and pick a data set and make it talk. So here comes Marion. I'm assuming they're all together, those people. Should I say the same thing to them? They're late.
How are you going to greet them?
Right, John? Finally, second shift showing up. Great. Marion. And comes Paris. So that's what we got left. Like all that, this sea of red here. And then I get a certificate suitable for framing and a coffee mug suitable for drinking. The homework, I think one question was from normality, the graph everybody kind of did. And then I think on ANOVA, I'm just asking everybody to do the data analysis pack. So if you haven't done that, go ahead and try that. And largely you're just highlighting, open the data analysis pack, find ANOVA single factor, highlight the data, and then this will pop out, and you'll have a F critical, and you'll have a test statistic that matches the test statistic from doing all the math. But let's not talk about hypothesis tests no more because we got through it. That's like rock bottom of this class, and we move on to more fun stuff. And that would be correlation, which I love. So we'll start out with this formula here. Correlation is, again, we're in the analyze phase. We've collected a lot of data. We've analyzed it for whatever reason. We're in the improve phase now, but we want to understand what we need to improve. And one way to do that would be to do some correlation stuff. So in this example, we're looking at, I have 10 subjects, 10 different ages, and 10 different salaries. And all I want to know is there a positive correlation between age and salary? As people age, they get older, does their salary go up? Using these 10 subjects here. All right. One of my favorite tools. No, I'm going to say my favorite tool is going to be what we call Pearson's R. And here's the formula for Pearson's R. And all I want to know is there a strong positive correlation between age and salary? Or is there a strong negative correlation between age and salary, and that is as you get older, your salary goes down. Or the third option is there's no correlation at all between age and salary. So a strong positive correlation between age and salary would be an R value that is very, very close to 1. All right, very, very close to the digit 1. A strong negative correlation, which means as my age goes up, my salary goes down, that would be a strong negative correlation, which would be -1. And if there's no correlation at all between age and salary, then I would have a R value of 0, which means no correlation at all. So the range for Pearson's R, we call it, is -1 to 1, where 1 is a strong positive. So the game is, if I have a strong correlation between data, age and salary, for example, if it's real strong, it's going to be 1. If it's pretty strong, it'll be 0.9, 0.8, something like that. If there's none, it'll be 0. And if it's negative, it'll obviously be in the negatives. And the homework is going to be to do the same thing, these 4 ways of getting Pearson's R, by looking at my weight versus my pulse. So I'm going to give you all my pulse data for the last 800 weeks and add it to the descriptive statistics. And you guys just go through these 4 steps, and it should take you 10 minutes maybe. We're not going to, the good news is we're not going to do the longhand method, but here's the longhand method just for, in case you ever get stranded on a deserted island and you want to do it. I always start with, all right, what's this thing asking me for? It's asking me for a bunch of sums. It's asking me to square things. That looks like about it. So I go ahead and did it. So the things that this formula is asking for, I need all my x's, which is age, squared. So I went ahead and did that. You can see these are all the square, 18 times 18, 25 times 25, etc. And that's asking me also for the sum of squares. So at the end, I add them up. And then it asks me to do the same thing with the y's. So you can see some y's that are squared in here in this formula. And then it asks me to multiply all my x's times all my y's and sum those up. Anyway, long story short, if you guys decided you're on a desert island or you hit rock bottom and you wanted to do Pearson's R longhand, you come up with a R value of 0.946. So I'd like to ask you, what is the correlation between age and salary based on these 10 subjects? Anyone? I'm going to pick on my star pupil, Joanne Marie.
Positive correlation.
Yep, strong positive correlation. Excellent. I picked on the right person. Exactly. It's very close to 1. So this is a method that I've never, other than for this class, I've never gone ahead and done it using this formula. But so the second way to do it, this is going to make you laugh because it's so simple, is I'm going to highlight my ages, I highlight my salaries, and this would be the homework for the pulse and weight. I'm going to insert a recommended chart, a scatter chart. I'm going to hit OK. And there's my chart. So as my age goes up, based on these 10 data points, so does my salary. And then I can right click on here and add a trend line. So I got a nice straight line. And then if you look over here in the format trend line box, if you drop it down, it says display R squared value on chart. So that's going to be my R value squared. So I don't get a negative number here. And you can see that it got added right onto the chart at 0.9846. So, I mean, that's close enough, I guess, to 0.946 that we did by hand, but there's some rounding. You can see how many digits we're talking about. So again, the scatter diagram also shows that I have a very strong positive correlation with these 10 subjects between age and salary. Another way to do it is use the Correl function, same idea, equals Correl. There it is, correlation. And it's asking me for array 1. and then comma array 2. So array 1 is here, and then comma, and array 2 is salary, hit enter, and I got 0.9923. Again, a very strong positive correlation. The fourth way to do it is using the data analysis pack, which is right here. And there's correlation right there. Grab that. I'll highlight my data. And the one thing in terms of highlighting the data here, you want to grab all of it together. Don't use the control function, to pick age, then salary. And then I do have the labels in the front row, in the first row, and I'm going to put it at P25. And correlation, again, 0.99228529, in case anybody's asking significant figures. So that's how you do correlation. So the homework would be to go back into descriptive statistics and using, I'm gonna have pulse added here for column C, and we'll have like 800 pieces of data, and all we want to know is there a correlation between my weight and my pulse rate? All right. Any questions about this? Really fun tool, easy one. Very powerful though. I think we'll see that in when you guys do the final presentations. It's really a good one to use. Whether you're looking at, I'm going to give you all my blood pressure and weight. If you do, if you do my data, or if you have other data that you're using, like scrap data or whatever you want to use, very powerful tool. I did make a note here, doing square root and power in Excel. Let's say the number 16. In order to do square root, there's a function equals square root, SQRT, and then you just pick cell A18, which is 16. It gives me the number 4. And then to do power, it just equals power, and then pick, in this case, I picked the number 4, and then comma to the second power. If I want to, if I want to do it to the third or fourth or fifth power, I just type in third or fourth or fifth. All right, so that's correlation. Any questions? Pretty good, right? Compared to what we've been doing for the last 2 weeks. There's Morgan Kaufman. And then I slide right into the PowerPoint. And today we're going to cover root cause analysis. How to pick projects, square root, and then correlation, which we'll fly through. So far we've been through the D, defining the problem and the objectives. What can we measure? How do we measure? Analyze ad nauseum with all the hypothesis tests. And now we're into some fun stuff, improve and control. And it's about redesigning the process to achieve improved capabilities. So we're going to improve something. And we're going to look at an increase. We're going to increase our focus on root cause and making sure that we are improving the root cause and not a symptom. And then applying various lean tools. So we're going to get into some lean tools next week, which is the fun part of this course. So today, selecting improvements. We're going to get into the fishbone, cause and effect diagram, and then we'll hit correlation and scatter plots. And next week, we'll get into regression analysis, which is also fun, residuals, all that, multiple linear regression. And then you guys are all familiar with these. So selecting improvements, again, in my own business, I had a really hard time working on big chunks of improvements at once. I had 80 employees, and I couldn't afford to have 10 or 12 people tied up in a conference room for 3 days very often. You can do it like once or twice a year, but I can't do it as a steady diet. So I think a lot of what we're going to go through in this course, the way this is laid out, the way the certification works is it's assuming that these are like long-term big projects, right? But that's not generally how people do Kaizen anymore. But when we look at impact, cost, and time are three high-level objectives. Balance desire with quantifiable evaluation, long-term versus short-term effectiveness. And again, as lean leaders, my feeling is we don't ever, if someone comes to us with an idea or suggestion, we don't ever just turn them away, right? Otherwise, they stop telling you, right? So, whatever they bring, sometimes they're long term, sometimes they're short term. If it's a long term project, in terms of getting to what gets to its effectiveness, then we're going to figure out how to ways to make it short term. We want to make sure that we can remove the root cause and not symptoms of the problem. We want to make sure that we're monitoring, we're able to measure the improvement. We want to make sure that we can inspect, online, some training and making sure that our improvement is sustained. And the costs that can consider might be initial training, materials, resources, equipments, etc. My feeling is if you're spending a lot of money doing improvement work, and this is not me, this is Taiichi Ono, then you're probably not doing it properly. Because like lean itself is about taking away, not adding things. It's about taking away the waste, in time increments, minutes of work, minutes of waste, hours of waste, seconds of waste, and doing it over and over. But I guess, you might want to consider in terms of ROI, one example might be at Ulbrich Steel, do we need a second wash line, for example? And they went through like 15 or 20 A3s, and they decided that no, we don't need it. We just need to make 18 or 20 improvements in the existing line. And they were able to take a $2 million line item out of the budget and not buy a second line. Time considerations. Again, I think just looking at time overall, and I'm kind of preaching to the choir here, with Marion, PTA, and Ulbrich Steel, in that, we're asking people to spend 15, 20 minutes a day working on the business as opposed to in it. We spend the rest of our time in the business, but it's taking the time because Monday turns into Friday afternoon really quickly. So the biggest struggle is busyness. That is the number one hurdle in improvement activity. I dealt with it all the time. We're too busy to get better. We're just Monday turns into Friday afternoon. There's a lot of competing priorities. So this is where lean particularly is about establishing routines where there may not be any, right? The roadblocks might be, these are real, I think, depending on the complexity of the improvement is, making sure, and this is the hardest part. I think this is the hardest part of doing improvement work is, all right, that sounds horrible. How do we measure it? And that usually can take 1 or 2 or 3 huddles to do it. And there's no, remember the concept of Nimawashi, proceed slowly, consider many options, gain agreement, implement rapidly. Most of our time is spent in define, measure, analyze. And then if that's done well, then we get to have some fun and do the improve and control. So let's talk about root cause. Forgive me if I've gone through this with you guys. I know most of you guys have probably heard this. 9 times out of 10, 8 times out of 10, when we look at root cause, so we've gone through define, measure, and analyze. Now we're asking, and a lot of times this is done in the analyze phase. This particular course, the way it's laid out, it happens to have it in the improve phase. But usually 5 why is the way we get to root cause. And the idea is that if we ask why 5 times, we're going to get to the true answer. And the example I always use, and again, I'm very, very sorry for those of you who heard me say this 3, 4 times. But the example I love to use is to teach 5 why is pretend that I wake up with a sore back once in a while. And again, by asking why 5 times, I'm going to get to the root cause. So once in a while, I wake up with a sore back, pretending, obviously. And I'm going to pull together a team, because I think the first instinct always has to be, and you guys all three, and I'm sure Paris, same thing. It's always, we always want to involve others, diversity of thinking. And this is so true with root cause. I cannot get to root cause alone. It's impossible. It's not going to happen. So I pulled together a team of my wife, my daughter, and one of my friends and say, I got this problem. I wake up with a sore back once in a while. What do you guys do when you get a sore back once in a while? Anybody? Morgan? I'm gonna start calling on people. How's
Stretch it
that?
out.
What's that, Jeff?
Stretch it out.
Stretch. Yep. Stretch. Maybe ice. Maybe head down to CVS. Get a painkiller.
You try
Maybe
to try to blame something on why my back hurts.
blame somebody else. Um, maybe get a massage. Who knows? So let's go through 5 whys. So the first question is, well, I get a sore back once in a while, and I have a team assembled because I'm not going to get to this conclusion alone. This is just a simple example. But my daughter might say, hey, Dad, it seems like you sleep on the couch a lot. So that's one why. Second why is, well, why do I sleep on the couch a lot? My wife might say, well, because you always forget our anniversary, Mother's Day, Valentine's Day, and we end up in a fight and you end up on the couch. Well, why do I forget? Because I'm not very organized and I don't use my phone to remind me that Valentine's Day is March 14th. And then I get in a fight with my wife and I end up on the couch. So instead of getting an aspirin or a massage or anything like that, all I need to do is learn how to program my phone to remind me. And again, that's a really, really simple example, but it holds true for most complicated problems. Now, there are cases, and I'm sure you guys have seen it, those of you guys have been around in terms of improvement work, where the root cause always seems to be we need to either retrain somebody or fire somebody or retrain someone or write somebody up or whatever. If that fifth why always seems to be a person, right? Or I have to retrain someone, well, then I might want to do this tool. And this is kind of how I look at it. It's like when we're always getting to because it's not the 5 who's, it's the 5 whys. But if I'm always getting to we need to retrain, then I want to use the Ishikawa, fishbone, or cause and effect diagram. They're all the same thing, right? And again, it's a brainstorming tool, very similar to some of the tools we saw, like the affinity diagram we saw earlier on. Same thing with PFEMA, doing the failure modes and effects analysis. It's not a thing. I'm not going to do a fishbone at my desk all by myself. It's just not gonna help at all. So it helps us to identify and organize and think about things that we may not think of normally, right? And I love using it when that fifth why is always somebody. Okay. The reason they call it fishbone is it looks like a fish skeleton when you're done, and it shows the relationship between the effect, the output, and the potential causes, all of the inputs. And the acronym that we use most often is P4M&E. So people is the P, 4M's is methods, machines, materials, and measurements, and E is the environment. All right. And we try to think of things that fall under those as a team, by leveraging the diversity of a 3 to 5 person team. 3 teams, with 3 to 5 people, ideal for doing both 5Y and also fishbone. So step 1 is identify and define the effect and state the operational definition of the effect. It can be a positive outcome or a negative problem that we're trying to solve. I'm going to give you an example of cooking bad burgers. Enter the effect in the end box of the fishbone. So that's the head and then the spine. And then brainstorm all the possible causes of that event happening. Kind of like we did the affinity diagram. And then Identify the main categories, which a lot of times is P4M&E. It doesn't have to be, but I think it's a good place to start. And below each major category, you can define subcategories, and then each cause category connected to the spine. So for example, measurements, is there a metric issue? Is it a valid measurement system? Did we calibrate maybe we didn't calibrate our equipment? Do we have enough data? Is the data readily available? Is it easy to get the data? That kind of thing. The people part might be, are people trained? Do they have the right skills? Is there person-to-person variation? Is there shift-to-shift variation? Is there somebody new on the line? Are people overworked? Are we pushing them too hard? Those are all kinds of considerations, but notice that we're not getting to the fifth why, which is people, but it just happens to be one of the things that we want to consider when we're building the fishbone. And then the methods would be, how is this performed? Are the procedures correct? Can people see them? Do they understand them? Are they in English? And maybe we have Spanish operators. What might be unusual here in terms of the methods and how we communicate the methods? Has it changed over time? Is our work instruction up to speed? Or is it outdated? Do we even follow it? And the materials are the bills of material current. Do we have a new supplier? Did we substitute in another raw material? Are there some defects that we may not know about in the materials? And the machines category is, have they been serviced recently? What's the uptime? Are we doing our PMs, our preventive maintenance stuff? Is there variation in the way they're running? And then the environment, is it safe and comfortable? Are outside regulations impacting the business? Does the company culture aid the process? You know, are people coming to work with their chins down? And you put them all on, you can see them all put on the fishbone, on the back of the fish. So why is the head? This is what we want to, this is our problem. And then you see 1, P4, P4, ME, and E. And then you analyze it. And you're looking at many, many more factors of the effect event being analyzed. We're looking at a whole bunch of them. Then you can use a Pareto chart to filter the causes, identify the high impact ones, and then do A3. Go make an improvement. Get it on the board and change one of them. And the benefits are, it helps us to quickly identify and sort potential causes. It's a systematic way, like Affinity and like SciPoc, to brainstorm potential causes, and also PFMEA identifies areas that need more information and helps us locate low-hanging fruit. And the limitations are, it's only qualitative. One cause and effect diagram can only focus on one effect or event at a time. And sometimes we've got to do further statistical analysis to quantify the relationship between various factors and the root cause. So you might have to go get more data, more information. That's fine. We just do not want to spend time putting a Band-Aid on symptoms. Like, I don't want to just go get an aspirin for my sore back. Here's an example that I stole from Wall Street Mojo. I like bad burgers. So there's P, personnel, 4 M's, machine, method, materials, and measurements, and E, the environment. So the things that are listed, like machines, storage, and cooking equipment. Poor hygiene, we're not cleaning it well enough. We're not maintaining it properly. Methods might be, you know, are we using the recipe properly? Have we trained people there? Is it being followed? Can we go ahead and do it according to the recipe and see if it comes out with a good burger? Materials, could be materials aren't fresh. I've got a really good deal on some burger that's a couple months old. It's not per our prescribed quality. It's not hygienic in terms of the packaging. And then the measurements might be incorrect quantity of spices. I'm asking people to put a pinch in and they're putting in half a tablespoon. Environment could be, a personnel might be on hygienic storage, insufficient training on how to cook and store. And the environment might be, it's too hot, will impact the quality of the food. Humidity might also affect the food quality. But we're going to come up with, all right, which ones are probably most likely, and we'll attack those first. So that's Fishbone. Fun tool. Correlation, we're going to fly through this. We're actually going to cover correlation, and next week we're going to start on linear regression. The correlation, it's a technique that describes whether and how strongly two or more variables are related, age and salary in this case. It helps us understand the direction, either plus or minus, positive or negative, degree of association between variables, and it suggests, and here's the cool part, because again, what our goal is, A, is our process capable of doing what we need it to do? And two, is it stable, which means can I predict with it, right? Can I predict what's going to happen? So of the different metrics to measure correlation, Pearson's R is the most popular, and it measures the linear relationship between two variables. It's a statistic that measures the linear relationship between two variables. So the range, as I explained, is from point -1 to 1. If Pearson's R equals 0, there's no linear relationship between the variables. And the sign of R indicates direction and also the strength of the relationship. So the closer I am, for example, if I have less than or equal to 0.5, then there is a weak linear correlation, a weak linear positive correlation. If it's greater than 0.5, then there's a strong linear correlation. So in the case of age versus salary, everything was 0.99 something. There's a strong linear correlation. And usually greater than 0.85 is what we use to determine a strong correlation. If it becomes 1, then there's a perfect linear correlation. And you notice we weren't at 1, but we were close. When the correlation is strong, the data points, when you do a scatter plot, will be very close together. So we saw with the age and salary between 0.8 and 1. So at 1, I have a perfectly straight line with all data points on that line, on that trend line. We got something less than that. We had a couple of data points that were off the line. And you'll see when we go the other way here, -1, that means, when I age, my salary is going to go down for those 10 subjects. It will be going in the other direction, which we did not see. At 0, I just have something that looks like the Milky Way in the middle. You wouldn't be able to draw a line through that. I'm really interested to see what you guys come up with weight versus pulse. So correlation doesn't imply causation, all right? If variable A is highly correlated with variable B, it doesn't mean that A causes B, or vice versa. It's possible that an unknown third variable, C, is causing both A and B to change. For example, if ice cream sales at the beach are highly correlated with the number of shark attacks, it doesn't imply that increased ice cream sales causes increased shark attacks. They're triggered by a third factor, warm weather, summer. It could be high or low by chance. It may have been calculated based on 2 small samples that do not provide good inference on the correlation between 2 populations. So in order to test whether there is a statistically significant relationship between 2 variables, we can run a hypothesis test, which I'm not going to get into because you guys are up to your eyebrows with it over the last 2 weeks. But we can do a hypothesis test to see if there's a correlation or no correlation. Enough said. So we can use the formula Corel in Excel, which we did, which is part of the homework. It's going to ask us for array A, highlight it, array B, after we type in equals Corel. A scatter plot helps us also reveal additional characteristics of the relationship. And the correlation coefficient doesn't replace the scatter plot in studying the variables relationship, does not cover all dependency patterns. So get into the XY diagram or scatter plot a little bit. It depicts the relationship between 2 variables, age and salary. And each point on the XY diagram represents a pair of X and Ys. We know how to do that. Again, here's the same slide. Perfect positive is all the way to the left. Perfect negative is all the way to the right. None is in the middle. And it helps us to spot interesting features of the data, but it doesn't provide quantitative conclusions that we can use. So there's a perfect positive. Don't you love doing math practice first? It just makes this so easy. This is a weak positive linear correlation. So you see data points that are off the line, but you can still draw a positive. It's in the right direction from left to right near the line. It is positive, but it's weak. And here I have uncorrelated. No correlation between X and Y. It doesn't matter how old I am, I'm going to get the same salary. And then I'm going to have some outliers probably, and those are the things we want to study, especially when we're tracking things like on-time delivery, we're tracking scrap, things like that. When we see outliers, we want to do further investigation, study those. They're clues for what happened. Oh my God, done. I'm going to stop there. 36 minutes. That's a lot better, isn't it? Don't you? It gotta be. Compared to hypothesis tests, 10 different times or 20 different types. Any questions, guys?
Nope.
Everybody's awake?
Mhm.
We're almost there. Homework, please. If you're behind, let's get it to me this week, because again, now we're gonna keep adding on homework for next couple weeks. You don't want to get too far behind. I will send you the slides. I think I already did, guys, on the invitation. I updated our invitation for today, and I attached the slides for the improve phase. And I'll send you math practice, and we'll call it a day. All right. Have a great rest of the day, guys.
Thanks, Bill.
Have a good one.
Thanks, you too.
Thanks, Bill. See ya.
Bye.
Thanks.